Assalamu alaikum, this is Rahila Rashid and my ID is 1830180. I'm going to start our 461 meet project presentation object recognition. The part I'm going to discuss is the robot building portion. For the floor setup of our world, we added a rectangular area from default setup which is mentioned here as rectangle arena, and also for the robot to detect some obstacles we have added some oil barrels, and for the light setup we have gone for directional light. Now for the physical structure of our robot, we have used a rectangular shaped body with 4 wheels attached to it. So for the body portion under robot, if we go under children node, we can see that we have defined the body shape, and for appearance we have selected PBR appearance, and for geometry we have selected box since it's rectangular shape. Also the cast shadows are turned true so that we get the proper reflection, and PBR appearance will make sure the better visualization. And the bounding object is use body, and we added physics to it. After that comes the wheels portion. For the wheels we have used 4 hinge joints. The hinge joints will help to rotate the robot. For the first hinge joint we have selected the joint parameter hinge joint parameters, and for device we have gone for a rotational motor and set the name to wheel 1. For the endpoint we have gone for endpoint solid, and over here we change the translation and rotation values. Under the children node we have defined the shape, wheel, and appearance, PBR appearance, and for geometry we have selected the shape cylinder here since it's wheels, and the cast shadows are turned true. An important point to note here that the translation and rotation values need to be set according to your body shape so that the wheels fit perfectly. Now for the bounding object, over here we have used wheel and also added physics to it. Now we have repeated the same process for the next 3 hinges, and thus we have got our basic structure of robot. Thank you.
Assalamu alaikum. My name is Faiza Firoz. I'm going to explain the distance and camera sensor. We use distance sensor and camera for object recognition. At first, we added the distance sensor node to the children part of the robot, and then we added the shape to the children node of the distance sensor. Then we gave an appearance to choose a box shape for the geometry. Also, we changed color and metalness to give it a better look. After that, we changed the translation point to move the sensor to the front part of the robot. And as the ray will be emitted along the x-axis, we had to rotate the sensor so that the x-axis is placed to the front side of the robot. Then, from rotation node, we changed the angle of sensor so that it can cover the front and right side of the robot. After that, we changed the scale value to give it a proper size and changed the name and added physics to it. In the same manner, we added another distance sensor to the left side of the robot and changed the translation so that it can cover the left side and the front side of the robot. We also attached a camera. To add this, we chose camera from the base node and then added this to the children node of the robot. Under children node, we gave it a sphere shape and gave it an appearance and renamed it. To move it to the front section, we changed the translation value and rotated. Then we moved it to the x-axis to the front side of the robot, and we added controller code to this controller node. This is how we added sensors and camera to the robot. Thank you.
Hello, my name is Rafsar Al-Mamun, and I will be presenting the last portion of our project. Here, we can see the controller code of our project, which we instantiated by choosing new robot controller from here and selecting CPP as the language. Here we have loaded a few libraries like distance sensor, motor, robot, and camera. Next, we defined the time step to be 64 milliseconds, meaning it will get and send data from the world every 64 milliseconds. Then we created a robot object and distance sensors and named them DS right and DS left. This needs to match the name of the distance sensors over here. As you can see, this is also DS right and DS left. Next, we declared a camera variable and enabled recognition. Its name is also the same as the device name over here, cam and cam. We then created wheels variables and named them wheel 1 to 4, which is the same as our rotational motor names, which you can find inside this hinge joint and then this device. Rotational motor, wheel 1, here's also wheel 1. The same also goes for the other hinge joints, wheel 2, wheel 3, wheel 4, same as this, wheel 2, wheel 3, wheel 4. We gave them an initial velocity of 1. However, when the robot encounters any obstacle, it will turn right. We then set the controller of the robot to this controller, as you can see over here. What we did next was change the anchor values of this hinge joint. See, this anchor values to match with the translation values of these wheels. This is to make sure that they have the same reference point. We did this for all the 4 hinge joints. Next, inside camera, we changed the width and height to 640 for better resolution, and also changed the field of view to 1. Next, we enabled recognition, and then we set the max range to be 100, meaning it can detect objects at a maximum of 100 units from it, and the max objects has been set to -1 to allow it to detect infinite objects in its path. We also set the frame color to red. So now our robot is complete, and let's have a demonstration. We have these obstacles on the floor for it to detect. Now, since these are pre-built, there was nothing to do. However, if obstacles were user-built, then we have to enable recognition colors of each obstacle so that they can be detected. So now, let's hit play. As you can see, there's a red frame around this object, meaning that the camera has detected this object. And once it faced that obstacle, the robot has moved to right and will continue on its path. Now, as you can see, it is detecting 2 objects, which resembles this and this object over here. So, that was all from us. Thank you.